All right. So on the computer screen here, I just have the worksheet and then a couple of the solutions, and then it'll just kind of audio record what we get for discussion here. So, hey Blake, you're looking sporty today. Why don't you take that there sock and pick a board for us here?
That was a miss.
It was not a miss. Hit the top.
You could just clarify, perhaps with another throw, which one of the. There we go. Okay. All right. So. Whoa, All right. Woo. I don't recall these characters from Harry Potter, but Joseph and Hiba, if you could pop on up. So the part I'd like you to chat with us about is part A. Those three problems. Just sort of discuss your thought process as to whether or not it was or was not CBPM.
So we said number 3 for problem for number 1 for like the Roman numeral 3 because it's the only one that like specifies that the 1500 meters is traveled with a constant velocity of 500. Because the other, you don't know, like it's like more acceleration for.
Whoa! Let's not make up words there.
Okay.
What is it in the problem statement for number 1 that tells you it's not constant velocity?
It starts moving.
So you see that wording in there. Starts moving indicates that it's probably not a CBPM problem. Okay. How about problem II? What is it about that one?
Traveling down before coming to a stop.
Before coming to a stop is the part of the statement that implies it's not constant velocity. Okay. And then you said for number 3.
It specifies traveling 1500 meters with a speed of 500. So.
It doesn't indicate at all that there's any kind of a coming to a stop or starting from rest. So for that reason, that one is the CBPM problem here. Okay, cool. Flip another board to talk to us about part B, 3 graphs and/or diagrams to describe the situation. All right. So this group who cannot be named. What up? Yeah. Well, you keep that facing out. What you doing? Come on, Hiba. Cheapers. All right. All right, that group. Talk to us about your 3 graphs and/or diagrams.
So we have 3 graphs. One is position versus time, one's position versus velocity, or time versus velocity, and one is the motion.
Okay.
So for our first.
So all I'm going to ask you guys to talk about is like generally the shape of them. So if it's a position versus time graph for CBPM, what should we see in the shape of the graph?
For position versus time, it should be linear because it's at a constant velocity. So.
Okay. For the velocity versus time graph, what should we see?
So straight horizontal line.
Straight horizontal line on a CBPM velocity versus time graph. And then if the motion map is CBPM, what should we see?
The arrow should be going in the same direction at a constant interval.
Constant interval. All right, cool. Go ahead and flip another board to talk about how to deal with this stuff quantitatively. Hey, drum stand.
That's why I'm strong.
All right, so drum string. We know 500 meters per second. We know 1,500 meters. Can you talk us through how we could leverage one of those graphs and/or diagrams to figure out the 3 seconds that you have there?
So if you look at the first graph we did, we can use that to come up with an equation.
Okay.
And we know the slope of that equation would be like the velocity of it.
Yep.
Which we do have on the second graph.
Okay.
So we set up the equation: position in meters equals 500 meters per second times the time, and we see that it hits 0, so there's no y-intercept.
Okay, so the plus b would be 0 here. And so,
And then you plug in the meters that you traveled into your position, and you get your time right.
there you go. So that's how to use the position versus time graph to figure out the time being 3 seconds. All right, flip another board to talk to us about the velocity time graph or the motion map.
Oh.
Spin it, not spin it, but flip it. All right, so same idea.
Jacob.
Same idea, but how would we do that from the velocity time graph or the motion map?
Like how would we figure out like the number of seconds?
Yep, from either the velocity time graph or the motion map.
Well, with velocity, we know that, or I guess we might be using distance. We know that it went, I guess it's kind of combination. Okay, we went 1,500 meters.
So you're talking velocity time graph then?
Yeah, I guess.
Okay, cool, because we just talked position time graphs.
Okay. Then we went 500 meters per second
Okay.
over 1,500 meters. So.
Okay, so how does the 500 meters per second show up on the velocity graph?
Just like a straight line.
I mean, it's your y-intercept, right? It's how high up you are. Okay. How does the 1,500 meters show up on the velocity versus time graph?
I mean, however many, like, the area, I guess, is what
Can you illustrate that there for us? Make that thing into a box and show us 1,500 meters.
So each one of those rectangles is 1 second,
And would have an area of,
500
there you go.
meters.
Okay, so takes three 500 meter rectangles to get 1,500 meters, and so therefore it would take 3 seconds. Okay, so that's leveraging the velocity versus time graph. You already get that. All right. Go ahead and flip another board to talk to us about the motion map and how we can use that to get the 3 seconds. Flip it. All right, here comes Gryffindor. Motion maps. How do we get the 3 seconds from the motion map?
3 seconds.
Rough.
That seems
Well, so we knew it had to travel 1,500 meters, and we knew it went 500 meters every second. So we just counted the number of like intervals we needed, and we got to 3
And
seconds.
the numbers are kind of small there. Can you write them a little bigger on the number line for the motion map so we can see what the positions are at those times?
3, 2,
No,
1.
put it on just like 0.
Yeah.
So like,
They're pretty
so
small.
you you're gonna have like 4 dots.
Yes.
Each dot supplies 1 second.
No. So,
Each dot represents
so this is what we need to talk about, the difference between a time reading and a time interval. What is the time reading for that dot you have circled?
0,
What's the time reading for the next dot?
1,
Then,
2, 3.
then. So there are 4 dots, but it's 3 intervals, and that's why it's 3 seconds.
Oh,
It's from time 0 to time 3 seconds. 3 intervals. All right, so that's how you would use the motion map to get 3 seconds, okay? So we've demonstrated how to use each of the different tools to do that. And then other questions. Man, so like what I'm kind of saying with T&E is the basic equation from the velocity time graph is area equals base times height. But then we make it physicsy by saying the area is a change of position, the base is the time, the height is the constant velocity. Okay. The basic equation from the position time graph is y equals mx plus b, but then we change it so it's position equals velocity times time plus the initial position. That's what makes it physics. Okay. So that's kind of what that's getting at. That's going to be a lot of this year. It's y equals mx plus b and area equals base times height. Sometimes area equals 1/2 base times height. Sometimes area equals base 1 plus base 2 over 2 times height. Okay, that's calculus. So, I've got this on the thing. And then let's chat about, so before we AFT it, make sure you send somebody by to erase your board. But I want to talk to you about the buggy challenges real quick. So over here on the canvas, this is on the same page. Whoa, scroll, man. Scroll. Not scrolling. Scroll. There we go. That works. Okay. So again, this is sort of your marshmallow check before the final test. There are 3 challenges, and I'm going to talk through them first, and then I'm going to explain to you how you're going to carry this out. Challenge 1 is this. You've got your buggy. It's a red buggy, it's a blue buggy. I don't know which one it is. You do, though. I'm going to mark out a target zone. You can kind of see it if you walk over here. You can see where it's been in years past. It'll be like a rectangular box marked out in tape on the floor. And that box, front to back, is 2 buggy legs. Okay? So right in the middle there, I'm going to call that position 0, and I'm going to drag a tape down that way. So that'll be 0 meters, and it'll carry on over to however many meters positive it goes to that wall. You need to figure out where along the number line does your buggy need to start, so that after 20 seconds, I've got this kind of drawn backwards. Imagine we're looking at it on the backboard. Your buggy starts wherever, so that after 20 seconds, part of it is in that target zone. Front wheels, back wheels, whatever. As long as some of it is in that target zone, you're golden. That's challenge 1, okay? And I have only drawn a red buggy. You may have a blue buggy. I apologize if you're offended. All right. Challenge 2. This is where you're going to need to work with that other group. Remember I said something way back when about if you're a red buggy group, make sure there's a blue buggy group that you can work with later. Okay? So the way this one's going to work is the blue buggy is going to be at the 0 meter mark. The red buggy is going to be at the 2 meter mark. And you're going to have to figure out, how far down the number line do they get before the blue buggy passes the red buggy. Where does the blue buggy take a lead? Here's that phone, bro. Cheapest. Wear bigger pockets. Bring back the 90s. Get the cargo shorts going. I'm sure Old Navy's still open in the mall. Actually, I got some pretty dope cargo shorts for cheap at Menards, buddy. I can hook you up. So. They got like the drawstring. You don't even have to wear a belt. All right. Challenge 3. The blue buggy is at 0. The red buggy is going to start at the 6 meter mark. Ooh. But they're going towards each other. You have to figure out where in this 6 meter continuum are they going to meet? Or who's going to win? Okay? So basically, you got like a physics game of chicken. Part of this, though, is demonstrating facility with the various problem-solving solutions that we just discussed with that worksheet. So here's the challenging aspect. I've got some graph paper over here. I would recommend working on that just to kind of work things out. This is graph paper of the double-sided variety. Okay. Superior. All the squares. So here's the part where you've got to listen, okay? Each group member needs to contribute to the solutions and must solve it using alternate approaches. So if Lucy decides to solve challenge 1 with a motion map, Donzi has to do something else. Position time graph, velocity time graph, or equations. Okay? But then for challenge 2, Lucy's already done her motion map solution. She needs to do some other way to solve challenge 2. She's going to have to do either a position time graph, velocity time graph, or equations to solve this one. Donzie just can't do whatever he did on problem 1 or what she's doing on problem 2. He can do a motion map here, okay? And then challenge 3, again, you cannot use the same method as your partner. You cannot use a method that you've already used yourself, okay? So in that way, hopefully we get a little variety. We can kind of check each other. It'll be bueno. That's going to come in on the graph paper, okay? The graph paper will allow you to do things like draw a scaled motion map. You're going to have to actually solve the motion map. Don't just do a motion map for show, but actually, as we just kind of illustrated, right, you can go 500, 500, 500 is 1,500. That takes 3 seconds, that type of thing, okay? Scale it with a ruler or with the grids. I'll leave that up to you. Yeah, so that's, you got time, 12, 13 minutes here to get working on this and get it sorted out. If you're a red buggy group, figure out which blue buggy group you're getting information from. You guys should know the speed of your buggy from that initial lab, right? So you know your buggy speed. Cool. Get that information to the other group so they can solve this. Simple enough? Do it.
I think so. You were with Joseph, right?
Oh, come on.
Let me find out.
You'll be Go.
I found the other one. Hi, you have.
And that's 25 years.
We have one apparently.
What? We have one.
Salida de balón siempre, pero lo que necesita Napoli en estos minutos de partido es la pausa que ha encontrado en esta acción con Mertens. Más adelantado quizás con un enganche y es el hombre encargado de dar esa pausa, tiene que parecer más sencilla. También Callejón lo hemos mencionado durante el partido. Entiendo que Mertens y Lozano necesita de sus jugadores. Por fuera ahí tiene que buscar el 1 contra 1. Entiendo que y Alexander Arnold son muy rápidos, pero al menos ponerles en esa superioridad. Pasado, la posición de Chucky es de 9, no es que falta de una de las dos bandas como definidora al segundo poste, no, es el punto de referencia en estos momentos.
That's the one you had. So that's kind of should be able to agree that. That seems like run the batteries down. No, run the batteries down. We'll start the car on tomorrow, man. So go with what numbers you have on your lap. If you have your lap, you know it's a speed.
del tiro de esquina y todavía sabe si se va a manejar y cruzar y un ataque peligroso, mejor lo corto.
So you do the buggy challenges as homework? Well, what? Yeah. If you don't get it done in class, homework tonight. Again, whatever you don't get done in class, that's homework tonight.
27 minutos de ritmo impresionante.
We have the third problem.
El problema es que le limita la banda verde, es que entiendo que sí lo es, que llega con el cuerpo, llega tarde. Choca con Alexander Arnold, la misma que le hacen aquí a Chuck, ¿no? Masti también llega, pero no está ni en la lucha, ni en el medio, y lo vemos, acaba chocando, y aquí sí es falta de verde, pero también si marcas una, sí es cruce,
How do ours get way over here?
Incluso el buen trabajo del lateral de Alexander Arnold hace que el centro no sea tan peligroso.
Don't forget to send a friend by to clean up your whiteboard before the end of the hour.
No sabe poner como mencionar, exteriorizar los valores, y en ese caso también la línea de cuatro
Hey, again, we got like 4 minutes left. Send somebody by to clean up your dry erase board. Yo. Uh-oh. They all have that same yellow key.
Hey, Matthew, I'm gonna do the motion. I'm gonna do the first thing. You do the other two. Last two. No, but we split the work. I do 1, 2, 3, 4. All right. On the buggy thing.
I don't think you can do that. I don't know.
Right, eventually that'll work. Hey peers, if you got questions or concerns on the buggy challenge left, hit me up. I'm in here. This is Champions League. Group stages.
I felt like it was literally just like months ago.
Right. What up? Omnis got you. So,
Is the thing homework tomorrow? We're gonna like figure out like all the problems.
yes. Yeah, what's the thing now?
That's all homework for tomorrow.
Right. Be ready to take classes.
So, for the buggy lab challenges, are they all due tomorrow or is
Yes.
it-
Yeah.
Wait, then how do we get the data for the rest?
You gotta ask that group. Or you gotta qualify. There's what is your blue one?
19.
What is the speed of your blue one?
Oh, I don't know.
Like 40 centimeters per second, something like that. Red one, I would ballpark it at like 19.
19?
Yeah, go with that and roughly just change it.
Okay.
Hey, seniors, if you are not aware or have not seen that yet,
alza posición adelantada y bien dices.
That was just so fun. So, like, I watched the
Ken, Chris, Raymond, Alex Wayne, Nicole, that's really now.
Oh yeah, we have 30 seconds.
Ha.